Okay, I'm going to talk about envy and the erosion of well-being, a heuristic mathematical model. And here is an image of a frog in a pot. I think you'll see that this is appropriate to this talk. Let me give an overview. In developed and developing societies, increases in prosperity are often accompanied by decreases in self-reported happiness. With several studies, including Japan, the United States, China, and other developing or developed societies, where more prosperity doesn't necessarily mean more happiness. But can we develop a heuristic mathematical understanding of this phenomenon? I don't want to give a quantitative model, but at least we can see the effects of this model as reflected in a mathematical model. So we'll use agent-based modeling to develop a mathematical model. And this model builds on the previous paper, Frogs in a Pot, an agent-based model of well-being versus prosperity, published in Springer Lecture Notes in Computer Science. Okay, let me give some assumptions of the model. I hope you'll find these reasonable. First of all, I'm going to study a subpopulation of agents. So this is a group of individuals within an entire population who look at each other, who consider each other as peers. Okay, that simplifies the model. Now, agents representing individuals or decision makers in the population, agents try to maximize their anticipated well-being. Of course, they'll try to make decisions about their life, about their jobs, about their purchases that will make them better off, according to their own estimation. Now, contributions to well-being include conspicuous and inconspicuous factors. Oswald Vleben talked about conspicuous consumption. Conspicuous factors are factors that are obvious to other people, including salary, house, material living. Also could be a civic involvement, things that are that people know about you that affect your well-being. On the other hand, there are inconspicuous factors, peace, reflection, private time with family, things that are not so open and obvious to others around you. Now, we suppose that new lifestyle opportunities are offered to agents based on current conspicuous norms. You know that job offers reflect people's current salary level. Things that are sold in the market because they're targeting people at their various income or their various lifestyle. But these targetings in the marketplace are based on the obvious or conspicuous aspects of people's lifestyle and not so much on the inconspicuous aspects. Now, agents' perceptions of their well-being is skewed because of envy. Agents overweight conspicuous factors in their choices. They care about what other people think about them, on the one hand, and also they think that others may be happier because they look at what others have, and they use that as a benchmark for their decisions and their judgments for personal well-being. Okay, so that's another aspect of the model that seems to be reflective of real conditions in real life. Now, the last one is that improvements in conspicuous well-being tend to come at the expense of inconspicuous factors. For instance, you may be able to get that better job, but at the expense of moving somewhere else, or higher pressure, less time with family. Now, this is not a hard trade-off, but a tendency that conspicuous advancement often requires some sacrifice in inconspicuous areas. Okay, so these are the basic assumptions that we mathematize in the model. Okay, and here's the simple model in mathematical form. We have a well-being index called WT of n for each agent n at each time t, and that well-being index consists of conspicuous and inconspicuous parts, A, T, and BT, respectively. Now, this is a relative index. We're not taking this as an absolute index. So really what we care about is the increase and decrease of this index. Now, we choose the distribution of these conspicuous and inconspicuous well-being indices with a bivariate normal distribution, and the uncertainty region is something like this ellipse here, where we measure conspicuous on the x-axis and inconspicuous on the right axis. So what this says is that if you have a choice or a lifestyle where conspicuous is favored, it tends to disfavor the inconspicuous index. That's the negative slope here, but it's only a tendency. There is a covariance ellipse, so there is a certain amount of randomness. And starting out at time 0, we center this ellipse at 0, 0. And this is going to drift over the lifetime of the system of agents. Okay, so this is the actual relative well-being of the agents, and each agent has a well-being that's chosen independently according to this common distribution. Now, on the other hand, the anticipated relative well-being of the agent, this is according to his estimation, is given by this expression. Now, notice it's almost the same as well-being, except for this factor Q, where Q represents the envy. So you see that the conspicuous are weighted more heavily because of this envy parameter. Okay. Now, at each time step in the model, at each time step, a certain fraction of the agents encounter the possibility of a significant lifestyle change. So they're going to make a choice which they will either accept or reject. These new lifestyle choices are also offered according to probability distribution. The covariance ellipse is the same, but this time the mean drifts along with the population. The mean conspicuous index for a new lifestyle choice is equal to the current mean of conspicuous indices of the current agents. The mean of the inconspicuous index has this negative correlation with the mean of the conspicuous index. And this again reflects the fact that inconspicuous factors tend to be sacrificed when conspicuous improvements are made in lifestyle. Okay, so that's how new choices take place. New choices are probabilistic, but the mean drifts along with the mean of the population. The mean agrees with the current mean of the population. Now, each agent who has a new lifestyle possibility doesn't necessarily accept that new lifestyle possibility. He'll accept it if he thinks that it will improve his anticipated well-being. So he makes a judgment on the basis of anticipated well-being. If the new lifestyle offer gives him an anticipated well-being that improves his current anticipated, then he will accept it. And if not, he may be forced to accept it with a probability P, which I call a misfortune probability. It may be that he encounters life circumstances that he has to step down a little bit because of things that go wrong. Okay, so if he can improve his anticipated well-being, he will choose definitely. If not, he may be forced to choose anyway. Okay, so let's characterize the behavior of this model. Okay. We have behavioral parameters. We have the envy parameter, which expresses the overweighting by agents of the conspicuous factors. We have the erosion parameter, which expresses the fact that improvements in conspicuous aspects of lifestyle tend to come at the expense of inconspicuous. We have the covariance factor, which gives the sharpness of the covariance ellipse, and we have the misfortune probability. Okay, and we use a certain range of parameters here. For us, we just used envy parameter as 0.75. We used various erosion parameters in comparison with the envy parameter. We used a covariance factor of 0, 0.7, and 1. A 1 corresponds to a circular distribution. 0 corresponds to a straight line distribution. And misfortune probability, either none or small misfortune probability. These other parameters basically just determine the speed at which the system evolves, so it doesn't affect the qualitative behavior. Okay, so we're going to focus especially on these key behavioral parameters. So let's see what happens. First of all, let's take the case where there's a straight line trade-off between conspicuous and inconspicuous. And that's shown by this scatter diagram. We show for 4 different values of k. This blue represents k equals 0.75. What that means is that improving the conspicuous only has a cost of 0.75, unit cost of 0.75 inconspicuous. 1.25 means the conspicuous cost is, unit cost is 1.25 conspicuous units. Then we have 1.75 and 2.25. All right. Now, these lines here represent lines of constant well-being. Okay. And these dotted lines represent lines of constant anticipated well-being. So you see they're different. Right. So notice that in this case with the blue, for instance, as you increase the blue, as you go to the right, you're crossing over this dotted line. That means these ones on the right end here have higher anticipated well-being than the ones over here. Agents tend to want to move towards the right. For this green, it's the same thing. If you compare this green slope to the dotted line slope, the right edge here is closer up to the advanced dotted line, which means that agents prefer to be to the right. And what that means is that agents will make choices that tend to move the system to the right. For the red is exactly on the line, so that it's kind of neutral. That means that agents aren't moved to the left or to the right. For the blue is steeper than the dotted line. That means that agents should prefer to move to the right. And in fact, that's what we observe in the system. This is the progress of actual well-being over time. And these dots represent snapshots of the system for the different values of trade-off parameter, different values of k. The red actually stays stationary, doesn't move. But you can see this blue system, for instance, it's moving in this direction. It's basically, if you think of this as a football field and these dotted lines as yard lines, the blue is moving down the football field. He's increasing his anticipated well-being. The same thing with the green. Note, however, that even though the system is moving in direction of increasing anticipated well-being, because of the overweighting due to the envy factor, the actual well-being is in fact decreasing. He's moving away from this solid line. So you can see that this green line is actually experiencing a decrease in well-being. Now this is the frogs in the pot phenomenon. That if you have a gradual decline in well-being, where the gradual decline in overall well-being is less than the envy factor, then the population will experience this drift and the population well-being will decrease, driven by people's choices, which are moved by envy. Now, this blue represents the fact where the case where the K parameter, the degradation parameter, is too large, larger than the envy factor, and people recognize that the conspicuous increases are too heavy a trade-off, so they're moving in the inconspicuous direction, and in fact, that brings the greatest increase in well-being. These other lines here represent the case where we have a small misfortune probability, and that only serves to slow down the trend slightly. It doesn't materially affect the trends. So you can see here this frogs in the pot phenomenon, that when the decay parameter k is less than the envy factor, so here we have this case where k is between 1 and 1 plus q, we actually have the well-being the actual well-being of the system decreases, even when people think their anticipated well-being is increasing. All right, now, suppose we change the uncertainty. In that case, we had straight line uncertainty. Now we do the case where the uncertainty is more elliptical. And the situation changes quite a bit. In the case where you have a gradual k, where k is less than 1, it doesn't change much. Also, in the green case, where k is between 1 and 1 plus q, we still see this decrease in well-being. We do see this initial increase due to the fact that there's uncertainty. People are crowding into the choices that are relatively advantageous. Remember, there's a covariance ellipse, so there are some choices that are more advantageous. People tend to accept those, and that drives up the mean, but then soon enough, the downward trend kicks in. The big change occurs in the case where k is 2.25. And what happens here is that the uncertainty, because there's uncertainty in the trade-off between conspicuous and inconspicuous, instead of getting the more inconspicuous choices, which eventually lead to better choices all around, people are still crowding towards the choices where it appears in the short term to improve the conspicuous index. People try to get those choices are exhausted, the system gets stuck, so it just remains stationary. However, when you add a misfortune probability, then the system has nowhere to go but down. Okay? So if you have this case where you have a large erosion parameter, and you also have a misfortune probability, then the well-being of the system goes down. And we see that in these dots here. In fact, not just the actual relative well-being is decreasing, but the anticipated well-being itself is going down. That's because when misfortune sets in, people have nowhere to go but down. They're trying to get the better conspicuous situations. Then when misfortune sets in, the only choice they have are ones which have an unfavorable trade-off between conspicuous and inconspicuous, because the society's drift has moved in the direction of conspicuous factors in well-being. Okay, this case shows the scatter. This is a scatter plot at the end of the time. This is a scatter plot at this final time. You see that if there's no misfortune parameter, it's very stretched out, still somewhat elliptical. If there's a misfortune parameter, it's much less spread out, much more circular. But what's happening is that people are all getting unfortunate choices over the course of the evolution, and once they have unfortunate choices, they're stuck. Okay. Now, the effect is even more marked when the uncertainty ellipse is less sharp. So this is a case where phi equals 1 is actually a circular uncertainty region for the individual choices. Still, the distributions become elliptical. But we can see that here is the case where you have misfortune probability. Again, we're seeing that when misfortune comes in, people are stuck. You have these people trailing back here who were lucky and didn't encounter misfortune. As soon as they encounter misfortune, they'll be brought down here, and they'll join the rest of the miserable company. Okay, and you can see here that in these cases that there's a very, very large effect of a small misfortune probability. The well-being goes way, way down. Okay, now this is really nothing new, although maybe not phrased quite in this way mathematically, but we see that over 2,000 or 3,000 years ago, we see similar conclusions being drawn. So thanks very much for listening. Hope you enjoyed the model.